Mark P. Otten back with you. Okay, so this is your R tutorial for a two-way ANOVA where both independent variables are dependent samples, independent variables. Okay, so let's take a look. The first step here is to reorganize our data, kind of like we did for a one-way dependent samples ANOVA. We got to make sure that R is going to read this in and interpret it the way we want it to. So on the right, we have an example that I used in our dependent samples SPSS, two-way dependent samples SPSS tutorial. And that was when we had three people. They were doing jumping jacks 4 times, time 1, time 2, in front of a female experimenter, and then time 1, time 2 in front of a male experimenter. And so this one was when we had participant 1 doing 0 jumping jacks every single time. Participant 2 did 0 in front of the female at time 1, did 2 in front of the female at time 2, and then 0 in front of the male both times. All right, so SPSS requires us to put participants in each participant corresponds to 1 row in the data set. Fairly simple in SPSS. However, when we convert over to R, we got to convert over to the format that you see on the left side here, where we've got participants going down the first column. So 3 participants repeated each 4 times. So you've got participant 1 in the first row, participant 2 in the second row, participant 3 in the third row, and then it repeats going down. Then you've got time points coded here. It looks a little bit more like an independent samples case in SPSS. So you've got time points coded as 1 and then 2 and then 1 and then 2 corresponding. Same thing for experimenter gender, 1 for female and 2 for male. And then finally the dependent variable in the last column. So let's take you through the first couple rows here just to clarify what the transition, what the switch looks like here. So the first row on the left, participant 1 at time 1 in front of a female experimenter, that's a 1 in the gender column, doing 0 jumping jacks. So that's this person here doing 0 jumping jacks on the right. The second row is participant on the left, is participant number 2, and it's going to be this person. Participant number 2 at time 1 in front of the female experimenter doing 0 jumping jacks. Then row 3, you finally get some jumping jacks. You've got this one. Row 3 on the left there is participant 3, time 1, female experimenter, 15 jumping jacks, and so on. So instead of the data looking like, 4 columns and 3 rows for SPSS, you've got all that data piled into column 4 for R under jumping jacks, the dependent variable, and then you've got some labels corresponding to which participant it was, which time point it was, and which gender the experimenter was. Okay, so if you get stuck in that process, just forget about it. No, just email me, let me know, talk to a TA. All right, so I'm going to switch over to R here. Once I converted the format there over, I imported the data set into R. It looks like this, should look exactly like it did in SPSS. And then we've got the code. So the code is just an expanded version of the one-way dependent samples ANOVA code that I showed you in a recent video. It's expanded because we've got 2 independent variables now, and that's pretty much the main expansion here. That's what that's why this thing looks a little longer. So first thing, the first row is just calling in the data set here, attach, and I've got my file name for my data set there as ANOVA 2IV2 for R. Then we've got participant, experimenter, gender, and time. Those are the columns of data in our data set that are aside from the dependent variable. So you leave out the dependent variable, which is jumps in this case, and you put in the 2 independent variables here, which are for us experimenter, gender, and time, and then you add an additional line for participant, and then each of these lines looks exactly the same as the other. So you're declaring all of these as factors. That's telling R, hey, we've got a couple of independent variables and we've got a participant column as well, denoting which participant the data corresponded to. So this is telling R it's allowing us to take that format of data that we just showed you and communicate it to R. So then we can go to our results statements here, and I ended up including two. I'm not sure that you will have to include two. The first one here is the primary one, and this is the one where you're setting up the two-way ANOVA. So you've got results. You can call it actually something else if you'd rather name this after your favorite celebrity. You don't have to call this results, but as long as it stays consistent with what you put in the next line, you're okay. So I called this results with the left arrow and the AOV denoting an ANOVA. Then we've got jumps here, which denotes the dependent variable. We've got time star exp gender. Those are our two independent variables with a star that's a capital 8 on your keyboard. In between, by the way, that was a tilde in between. So this is a format that is starting to repeat a little bit for us with the tilde, the dependent variable to the left of it, the independent variables to the right, in this case with a star in between, suggesting that we want to not only look at main effects here, but we want to look at an interaction between the two. Then we've got plus error, and for a one-way design, we just had participant star something, whatever the independent variable was. Here we've got two independent variables, so we're repeating this time star exp gender. It matches what we put in earlier in this line of code. So participant slash time star exp gender corresponds to the participant number and the two IVs after the slash there. And this is just setting up the math for R to tell us what the results are. So when I set this up, I thought I was done, but then it didn't give me the exp gender main effect result. And so I added in this second round of results here. This is just specifying, for me, it was necessary to do this to specify the exp gender main effect in addition to the time main effect and the interaction term, which were specified already when I ran it just with the line above. So to get that other main effect, I just dropped time from the equation here. So it's just jumps tilde exp gender without the time star in there, and then also without the time star here in the error term. So it's just participant slash exp gender. So again, this is just to get the exp gender main effect because it didn't give it to me the first time. If you get both main effects and an interaction by just running this, then you're good. I didn't, so I ended up running an additional 2 lines of code there. All right, just let me know if there's questions as you go along creating this code, if you get an error message or something like that. I'm gonna hit run here. It's a little bit longer since like I said, there's 2 rounds of results that I ran. So I'm gonna scroll up here to the beginning to show you the first thing here, which is the time main effect p-value 0.517. It's under error participant : time hiding there, but it's got the sum of squares 10.08. The f value is 0.608 for that main effect. And the p-value, like I said, is 0.517, greater than 0.05, so no main effect of time, not a significant one anyway. Then we go down here for the interaction, time : exp gender, going across sum of squares 6.75, f 2.08, and the p-value 0.29, so no significant main effect of, no significant interaction. No significant interaction between time and experimenter gender. And then what I needed to do, that second line of results yielded this additional line of key numbers here. This is for the experimenter gender main effect, p-value 0.36, greater than 0.05, so no significant main effect of experimenter gender. All right, that's your 2-way ANOVA for dependent samples, or when both independent variables are dependent samples. Okay, hope you're enjoying learning about R. If you get this code to run and there's no error, just take a minute to celebrate. Like, hey, I know what I'm doing here. This is exciting.